When adding and subtracting polynomials, you want to look at the operation sign that's shown between the parentheses. So that could be a plus sign, a minus sign, or if you see parentheses next to each other, that's an indication that you will be multiplying. When you have a subtraction polynomial, what you want to do is you want to make sure that you distribute that negative sign that's shown before that set of parentheses to the next, to all of the terms in that next set of parentheses. So something like this. So if you see the subtraction sign that's in between, if there are numbers, or we'll just use variables here, I need to distribute this negative to change the sign of every term that's inside of the parentheses that's next to it. So I don't do anything with the parentheses that's in front, or if there's a set of parentheses that's after, unless there's another negative sign. So I'm only focused on the parentheses, all of the terms that are next to that negative sign that's in between the set of parentheses. Finally, I want to write my answer in standard form, which means that I'm going from the highest exponent, which is like, say for instance, x to the third power, and then I go and I list in descending order. So x cubed, x squared, x, so on and so forth. So like for this first example, the first thing I look at is the sign. So I have a plus sign here, and if I have a plus sign, that's just telling me that I do not have to do anything except drop those parentheses. What I typically do is I look at the first set of parentheses, and then I start trying to match like terms in all of my other sets of parentheses, looking at my variable in the exponent. So this one I have b cubed, so I'm going to look in the second set and see if I have anything that has a b cubed, and I do. So I'm going to color code so I can tell that those two go together. If I have b to the fourth in the first set of parentheses, I'm going to look in the second set and I see another b to the fourth, and I'm also including the sign with it. Here I see that I have a b, but when I look in the second set of parentheses, I don't see a b, so I know that's going to stand by itself. And then finally, on the second set of parentheses, I have a positive 5 that's left over. Now that I've accounted for all of my terms, I'm going to start combining them. You could go ahead and start combining them horizontally. I personally like to do math vertically. So for where I see 6 2b cubed, and I see a 6b cubed, I'm going to add those together. Because again, I'm using the sign that is in front of that term. For the purples, I'm going to bring this one over. It's still a 6b, but this time it's to the fourth power. And then again, b does not have a match, and plus 5 doesn't have a match. However, so that I don't forget to bring that information down, I can either draw an arrow or I can write plus 0, and that will help me to remember to include that information as well. And the other two, just once you account for them, so 6b to the third, you can go ahead and just scratch that out, which is what I just did. And now add your like terms. 2 plus 6 is 8. And when you're adding or subtracting polynomials, do nothing to the exponents. You just bring it down. Plus, so 3 plus 6 is 9. And again, just bring down that exponent. This is just positive b. 5 plus 0 is 5. You would think that you're finished, but you're not, because remember, I stated that you need to start with your highest exponent and count in descending order. So 9b to the fourth power is going to go first. And then you look for the next highest exponent, which is positive 8b cubed. We don't have a square, but the next highest exponent is b to the first. And then we have positive 5. This is the final answer. It's in standard form. You just simplified, which means you combined all your like terms. You do not have to try to factor out anything. This is your answer. The next example, when I look at the sign that's in between, I notice I have a subtraction sign. When I have a subtraction sign, that's going to affect every term that follows it in this set of parentheses only. So this is really a negative times a positive, which is going to change this sign, and the same here, same here. When I rewrite this, negative times 1 is negative 1. Negative times 4x to the fourth power is negative 4x to the fourth power. And then negative times positive 7x is negative 7x cubed. Once I get to that point, I can go ahead and get rid of that. I'm no longer working with that. I'm only working with my new change. And now I'm going to do what I did a few minutes ago, and I'm going to try to match up what I can. So in my first set of parentheses, I have x to the third power. I also have an x to the third power. I have a x to the fourth power. And in my second set, I have an x to the fourth power. But this time I have two constants. A constant is a number that does not have a variable. So I can combine those. That's what we're doing. We're combining like terms. You, again, if you can see it horizontally, go ahead and do it. I'm going to personally go ahead and combine them by setting them up vertically. So including the sign, negative 7x cubed minus 4x to the fourth, and then minus 1. And again, once I account for them, I can get rid of it so it's not confusing to me. And this is what I'm left with. When I start simplifying, 7 minus 7 is 0. So I won't have an x cubed term. Negative x fourth is really negative 1. And then I combine negative 1 plus negative 4, which is negative 5, bring down x to the fourth power. 3 minus 1 is positive 2. So it is in standard form, which means I am finished. I don't try to factor, I'm finished. And as you notice, it's okay to lose an exponent because if it's 0, that means it no longer appears in your answer. For example 3, now this looks confusing. So we're going to use that same strategy. Luckily, we have a plus sign and a plus sign, which means that we are not trying to change any of the signs in the parentheses that follow. All we're doing is taking the variable and its exponent and we're combining them. So for the first set, I have a b squared. So I'm looking for another a b squared. And then I have a third set of parentheses this time, so let's look there as well, a b squared. So all three of those can be combined into one number. That's what we're trying to do. The second term is negative 4a to the fourth, 2a to the fourth, and positive 8a to the fourth. We've run out of terms in the first set of parentheses. However, I still have information unaccounted that's not highlighted for in the second and the third set of parentheses. So let's see if we can combine those. A to the third b, a to the third b. Now, this is why highlighters or colored pencils come in handy. So you can clearly see that all of the terms have been accounted for. Now we just simply simplify them. So what I would do so that it's not as confusing is I would just look at the number portion. So I'm going to work only with the orange, and to the side I'm going to write 4 because that's the coefficient, negative 1, and negative 3. And once I simplify this, I have 4 minus 1, which is positive 3, and 3 minus 3, which is 0. So I know I won't have a term that has an a, b squared in it. So I'm going to get rid of those, and it won't be in my answer because the answer was a 0. I'm going to go to the purple one, and that's the negative 4, positive 2, positive 8. Negative 4 plus 2 is negative 2. Negative 2 plus 8 is a positive 6. So I do know that this is going to be one of my answers, so I'm going to go ahead and write that, 6, and then I take on the variable and the exponent, a to the fourth. And since I have taken care of all of the purple, I'm going to go ahead and scratch that out. Next, I'm going to move on to the reds. So that's a negative 1. That's a negative 7. And when I combine them, I have a negative 8. So I know I'm going to write -8, and then I bring down the variable in exponents, a cubed b. This is my answer. If I want to make sure that it's in the correct order, don't know what happened. Okay, there we go. The standard form, when it has multiple variables, I typically just choose one of them to work with. So a to the fourth, a to the third, and b just happens to be there. So that's how I set it up. This last one, again, it looks really confusing, but let's just use our strategy that we know. First things first, look at the signs. This time I have a negative, which means that every term that follows in this set of parentheses will be affected. I will not affect the signs of the parentheses after that because there's a plus sign in front of that set of parentheses. So it only affects the one that's next to it. I won't mess with this one either because there's an understood plus sign there. So I'm going to use my same strategy, which is looking for x cubed y to the fourth, x cubed y to the fourth, x cubed y to the fourth, xy. Now here, before I do that, I should have actually, let's just change our sign so we won't forget to do that. So negative times negative is going to result in a positive 7xy. Negative times positive will result in a negative 7x cubed y to the fourth. Negative times negative will result in a positive 7x squared y squared. Get rid of that. Let me go back and put now. That way we won't get confused. All right, so now going back to my xy. Here's an xy and there's an xy. Don't forget your signs. I've run out of terms in my first set of parentheses, but my second one I still have x squared y squared. And if I look over here, this is not the same as x squared y to the fourth. So don't get confused just because you see an x squared and x squared, everything has to be the same. So this is going to be by itself. When I look at this, I see that all of my terms are accounted for. And I'm going to get rid of this because that's going to confuse somebody. And now I'm going to line up my numbers. When I do that, I have a -7. I'm only working with the oranges. Another -7, and a -6. -7, -7, -14, -14 plus -6, -20. So I know that's going to be a part of my answer. I'm going to write -20 and then bring down the variables x cubed y to the fourth. Get rid of that so it is no longer confusing me. I go to the next one, 5, and I'm only looking at purple. So 5, 7, and another 7. 12 plus 7 is 19. So I know I have a 19xy. And then I'm going to go to the red or the yellow. So it really doesn't matter, but I'm going to choose this one because even though they both have the x squared, the y has a 4, and remember we're going to count in descending order. So since that's 4 and then this is 2, I'm going to go ahead and put this one first. -5xy, I'm sorry, x squared y to the fourth. And since there's not anything to go with the red, I can just bring that down, plus 7x squared y squared. Now I want to rewrite it in standard form. So, oops, let's find another color here. Let's use orange. So if I'm using my x to the third, I want x squared to come next. So -20x to the third, y to the fourth, minus 5x squared, y to the fourth, plus 7x squared, y squared, plus 19x, y. This is how I would set it in standard form, because again, I'm looking at my x variables, x cubed, x squared, another x squared, and then x. And it just so happens that these y's both have a 4, and then it counts down to 2 and 1. So this is how I would actually leave that answer. And that's it when you're trying to add and subtract polynomials. So you know the routine. Please like and subscribe. I truly appreciate it. All right, you guys. Have an awesome day.